Okay, good morning. Today's topic is IoT devices and input devices. Here, IoT devices consist of different IoT devices are there. Raspberry Pi, one IoT device, Arduino interface, another IoT device. Like that, different devices are there. Here, you are going to know about the what is a IoT device and then some example as well as the Raspberry Pi and then how can you what are the components of Raspberry Pi like that you will know about the different things here the IoT devices. I think you have a great idea about the IoT device. IoT device in the sense or it is a anything, any item, a fan, light, a tube light, or anything here that's having unique identity that performing remote sensing and activation monitoring capabilities. Then only such kind of devices are called as a IoT devices. Some of the example for the IoT devices here is a smartphone, smart TV, so a computer, refrigerator, car. These are all IoT devices. Here, let us assume a simple information about the IoT devices. Here, the IoT device in the sense that's having the a special thing. It's not a physical device. Physical device in the sense ordinary fan is a physical device. If the fan having the IP address is having sensing capability, it's work with the internet, then that is called here IoT device. Here, these all IoT devices having a special capabilities that's called here those type of objects. So what are the special capability? Activating capability, digital capability, network capability. These are all called it as a smart IoT. The smartness in IoT, these objects are called as a smart object. If it comes to the light, if it comes to the fan, if it comes to the mobile, if it comes to the car, these are all connected each other. Here send data from one device to another device. That's called here. This type of devices are called as a smart devices. These are all called as IoT devices. Here some of the things, for example, smart home system, smart cities are the different IoT devices here. And then these IoT devices exchange data from one data to another device. Here, IoT device includes a computer devices, software, as well as the sensor and actuators. Here, IoT devices are connected over the internet. That is a main important point. Here, for example, here have some example of the IoT devices. Home automation device. One kind of device here is a home automation. For home automation, you are connecting different things to the mobile phone or laptop. Here allows remotely monitoring the status of a appliances. All appliances in our home we have a different appliances are there. Either a tube light, either a surveillance camera. Here anything here it will identify the status of a all appliances. For example, that's a home automation device. The diagram indicates the home automation device diagram. And then industrial machine is a one of the example here. Here which sends the information about the operation and health monitoring data to the server. Here what is the industrial mission here? That means it sends information about the operation and health monitoring data. Here different parts of a that means it will send some server. That is a industrial automation system. Here coming to the car. Here car is a one type of example for the IoT device. Here car sends a information about the location to the cloud. That means the bottom of the top of the diagram indicates the cloud based information, and bottom car it sends a some information to the cloud based computing services. That is a thing. And then uh, wireless enabled wearable devices here. Another one wireless, that means what is the wireless enabled devices here? These devices you that means measures data about the person. Here such as the a number of steps walked and send data to the cloud based services. Here this is a different examples. Here you have a building blocks of IoT. Since I think you have idea previously, sensing capability, activation capability, communication capability, analysis and processing capability. These are all building blocks of IoT system. Always each and every IoT device and the these information. Here the IoT device consists of, that means device in the sense It's having some kind of component for interfacing with the other devices. Why? Because the IoT devices sends the data to one device to other device. Here you have some connectivity interfaces are there, processors are there. That means some of the components existed in a IoT device, and then graphics, and then audio video interfaces are there, memory interfaces, storage interfaces. Some of the interfaces here, special kind of interfaces, SPI, I2C, CAN, UART, like that. You have a different interfaces. That means the diagram, the block diagram consists of different component. This component interfacing to the other things here. For example, USB host, Ethernet for providing the connectivity to the internet. Like that, you have a different interface devices are there. Here, for example, these are all the IO interfaces for the sensor, interfaces for the internet connectivity, memory and storage interfaces, audio and video interfaces are there. These are all different block diagram interfaces. You have a, I think you have some certain properties are there. Here, the IoT devices having the sensing probability, send and receiving data probability. That means these properties, sensing data. That means sending data to. That means it will sense the data. Sensing in the sense retrieving the physical parameter from the environment, retrieving the physical parameter from the environment. That's called and send receive data. Here it will send the data to other devices, or it will send the data to servers. It will send. That means this type of information done by using IoT devices. Here anything done by with the help of over the internet connection. Analyzing capability, analyzing. Here it will analyze the data coming from the server or send to the server. Here controlling capability. Here endpoint. That means IoT device may control from some endpoint. Here IoT devices are themselves communicate with each other. Here at least two. That means without failure of system. These are all property. Very important thing here is a IoT devices, different types of IoT devices. You are having different types of IoT devices. One is a accessories devices. Here sensors, activators, switches, display. You will discuss in next concept about the accessory devices. Here next ordinary, that means embedded system based devices. Some of the devices are embedded system. Arduino, one type of system based device. Raspberry Pi, the next class, the next thing. That means you are going to know about the Raspberry Pi. Here that means some of the cubic boards. So that means you are not discussing this cubic board. Intel Galileo. That means in the first unit you discussed about the Intel Galileo, how it will works. And then you will discuss here clearly about the Raspberry Pi and then Arduino. Okay, these two devices. Coming to the wearable devices, already you have Google Glasses, one type of wearable devices, watches. Here on type of devices like that, you have a different devices are there. The next coming class, that means you will discuss about the Raspberry Pi. The important concept here, the Raspberry Pi and Arduino. Here, the devices here, IoT device in the sense, the representation of IoT device is a single board mini computer. Here is called here Raspberry Pi. It is the representation here. How can you represent the Raspberry Pi, not IoT device? The representation of IoT device is called Raspberry Pi. Or the Raspberry Pi or IoT device, both are similar. One type of IoT device, Raspberry Pi. Raspberry Pi IoT, why it is as Raspberry Pi IoT device? It's having the sensing capability. It's having the analysis capability. It's having the different sending and receiving capability. Then only this is called here Raspberry Pi is a IoT device. Here, what is a Raspberry Pi? The Raspberry Pi is a low-cost mini computer with a physical size of credit card size. With the credit card or debit card size, it will come here. That is a Raspberry Pi. Here you will know about the Raspberry Pi, and then that means next coming section you will know about the Raspberry Pi programming with Python, and then after that you will know about the Arduino interfaces, and then some of the other IoT devices. Here this is a some description about the IoT devices. Here coming to the best example for the IoT device here is a Raspberry Pi. What is a Raspberry Pi here? Here, what is a Raspberry Pi? Raspberry Pi is a low cost mini computer with physical size of credit card size. The size of the Raspberry Pi here, the right side diagram indicates the size of the Raspberry Pi is a credit card size. Here, the Raspberry Pi consists of different components here. Here, what are the different components? Audio jack. As I previously, the device in the sense audio jack. In order to, that means audio and then RCA video and then GPIO header, GPIO pins. These are all called, the right diagram indicates the GPIO pins, and then SD card. Under the Raspberry Pi, you have a SD card. You will inserting the SD card. Why? Because the Raspberry Pi not having any storage. Here, not having any operating system. You will install the operating system in a SD card. That means you will store the operating system in a SD card and then you will install. It's not having any operating system itself, having not having any operating system and storage. But here you may insert the SD card. For inserting the SD card, you have a SD card slot under the Raspberry Pi. Here, that and other one here is a micro USB power, HDMI, HDMI for a video, uh, audio interface. This one, and then Ethernet. Here, in order to providing the internet here, you will use a Ethernet interface. Here, in the component, these components all are called as a. These all components are called as a. What is these components? Interfaces. Already you discussed in a previous session about the IoT interfaces. Here, another important one here is a Raspberry Pi runs on a different flavors of Linux. Here, all flavors of Linux. Here, Ubuntu Linux, and then Raspbian, and then Nudes, like that, different flavors of Linux. That means the Raspberry Pi perform almost all tasks that normal desktop computer can do. Here, whatever may be the task done by the normal computer, that means those all tasks done by the Raspberry Pi. What are the tasks done by the normal computer here? The normal computer, from the normal computer, by using normal computer, you will browse the internet, and then you will performing some of the word processing. Here, word processing in the sense you will type the some books or something else, word processing. And then other important thing here, by using computer you can perform, you can play the games. Here, by using this Ras- Raspberry Pi also, you can perform in the different games. Here, whatever may be the work, whatever may be the task done by the ordinary computer, those tasks done by the our Raspberry Pi. Here, that's why Raspberry Pi is a fully functional computer. Yes, which is called as a fully functional computer. Why? Because fully functional computer, it's having the browsing capability, Raspberry Pi, and then it's having the word processing capability, it's having the playing games capability, and then by using Raspberry Pi you will develop the IoT based application. Here, different any IoT based, the home automation system, smart cities, uh, a smart environment, like that. You will perform the any all developing the IoT based applications, different IoT based application only by using this Raspberry Pi. I think you have clear idea about that one. Here, Raspberry Pi allows interfacing sensors and activators here. Here, which will allows the different interfacing sensor. Here, by using general purpose GPIO pins. Here you have a, the diagram here shows the pins. Some of the pins are there. GPIO pins. Here, by with the help of, that means I can show you the GPIO pins. Here, these are all GPIO pins. Here, these are all our GPIO pins. Here, with the help of GPIO pins, you will perform the interfacing. Here, that is called here, that is a Raspberry Pi. Here, Raspberry Pi runs on a operating system. It supports the Python out of the box. Here, always the Raspberry Pi in the sense Raspberry in the sense Raspberry, and then Pi in the sense Python programming. Here, always Raspberry Pi supports the Python programming. Here, and then it consider the superior at a software application. Always the Raspberry Pi consider a superior at a different application. Here if you see here, general purpose input output pins, here these are all, that means this is a latest version. I am showing the versions, different version. For example, it is a old version, different versions are there. One 2 point Raspberry Pi 2, Raspberry Pi 3, it's a 2. I think this is a 500 MB RAM, this consists of, it's a 2. The next version, this is a 3, Raspberry Pi 3, this one, different versions. Here, nowadays you are using the Raspberry Pi 4. Here, the Raspberry Pi 4 having the different things here. IoT port, IoT port, that means Ethernet port for internet connectivity, USB cable like this, and then AV jack. Here, Raspberry Pi 4, HDMI port, video, audio, and then camera module is there, USB power port is there. Here, and then here comes to here, an external display port, micro SD card slot, different slots are there. Here, this is called Raspberry Pi 4, Raspberry Pi 4, that means different versions came. Here, this is a, it is considered superior at a software application. It was developed to encourage the basic learning for the computer science student. Here, for the students, children's, the basic learning for the computer science and other growing countries. That means it consists of 64 squad processor and microprocessor. It's having the 64-bit quad core processor. Here, other important thing here is a Raspberry Pi 1 GB of RAM. Here, if you comes to the 1 GB of RAM, there's a new version. Here, old version consists of 500 GB of RAM, like that. Here, 256 of RAM, like that. But I am telling you about the new version, Raspberry Pi 4. Raspberry Pi 4 having the 1 GB of RAM, and then the foundation of Raspberry Pi provides the operating system such as Linux. Here always it's having the Linux operating system. It provides a non-Linux operating system also. It also provides a non-Linux operating system, Open BSSD. I don't know about this operating system, and then Net BSD, Helen OS, like that. It supports the non-Linux operating systems also. Here, the types of Raspberry Pi are Raspberry Pi Alternative, Raspberry Pi Zero W, Raspberry Pi 3 model B plus. You can run all types of application in a Raspberry Pi. Here, which type of application you may run here? Microsoft Office also you can run in a Raspberry Pi. Emails, you will transferring the mails from one person to another person, and then specific code for an electronic projects. That means you can performing all these different tasks by using Raspberry Pi. And then one important thing here is you can run a single or different pieces of code in a Raspberry Pi. Here you can run the different code in a ordinary computer, that can be done in by using Raspberry Pi, since Raspberry Pi is a mini computer. Here other important things here is the operating system, all the files. So that means the Raspberry Pi does not having the any storage. It's not having any operating system, but here the operating system in all files is saved in a SD card. Here that means you take the operating system in a SD card and then put in a slot. They are providing a one slot for SD card. Place that one in a SD card. Here for one Raspberry Pi you can have the multiple SD cards for different operating system and file system. Here you may use the multiple SD cards for the one operating system. It is a consistent in many programming languages. Here it is easily connected to the internet. Why? Because how can you connect the internet here? By using, there is a one slot is there, Ethernet slot. By using this Ethernet slot here, you will easily connect it to the internet. That is a thing. Another important one here is the design of Raspberry board consists of different parts. CPU is there, ordinary computer has the CPU like that, it has the CPU. GPU, graphical processing unit, graphics, audio video files. For performing that one you will use a graphics thing. And then RAM, and then Zigbee port also there, Ethernet port also there, and then different ports, and then UART, asynchronous receiver or transmitter port is there, and then GPIO, general purpose input output pins are there, different general purpose and output pins. Here some other important thing about the Raspberry Pi here comes to the 4 point, I think 4. Raspberry Pi ranges from the 7 megahertz to 1.5 gigahertz. Hard drive here, that means there is a slot, the slot on the board which is called here, that means there is a hard drive for the Raspberry Pi is the slot on the board in which the SD card is inserted. That means you can insert the SD card on a hard drive. The Raspberry Pi having the capability here converting the analog to digital. For that purpose we are using the analog to digital converter is attached to the Raspberry Pi. Raspberry Pi having a 40 input output pins on the board. Here we have a 40 pins are there. Here it consists of input and output pins. Here GPIO pins are different from input and output pins. That is some information about the Raspberry Pi. Here this is the components of a Raspberry. In the next section we will discuss about the components of a Raspberry Pi. Here these are all different components of a Raspberry Pi. One is a SDMI, and then CSI computer camera, Ethernet, USB, status LED, audio jack, RCA video, GPIO header, like that SD card slot, USB power, like that you have a different slots are there. The first thing here is a processor and RAM. The Raspberry Pi components consist of processor and RAM. I am telling you this one as per our book. This is a old version. That means it's based on a RAM processor. RAM, this particular Raspberry Pi based on a RES processor. The latest version, model B, revision 2. That means at the time of getting the book, it is a latest version 3. This comes with the 700 megahertz low power and 512 MB RAM. That is a old version. This one. Nowadays, you are using the 1 GB RAM also, and then USB ports are there. Here, USB ports. See here, different USB ports are there. What is the purpose of USB port here? The two USB 2.2 USB 2.0 ports are there. It provides a current up to 100 amps, milliamps. And then for connecting the devices that draw the current more than milliamps, external USB power is required for this one. That means some information about this one. Other kind of information here is a Ethernet ports here. Here, if you come to the right side of the diagram, the Ethernet port is there. Here, what is the main purpose of this Ethernet port here? This Ethernet port used to providing the internet connectivity. Here you can connect, that means you can connect an Ethernet cable or USB Wi-Fi adapter to provide the internet connectivity. Here you will connect the wireless cable or Ethernet cable or USB Wi-Fi adapter also. Here you may connect. With the help of this Ethernet, here you will provide the this internet connectivity. Other one here is a SDMI output here. What is an SDMI output here in this case? Here under the diagram, there is a SDMI port is there. What is an SDMI port here? The HDMI port provides a both video and audio output. Video, that means by using this port here, you will display the data. That means you may connect to the simply monitor, or you may connect to the simply your TV. So that means from the TV here itself, you may convert it into computer. Why? Because TV is a one type of monitor. Here you may connect the TV. That means all type of TVs. In order to connecting the whole type of TV, you are using the HDMI. Here you can connect the Raspberry Pi to monitor using HDMI cable. Okay, HDMI output. Here comes to the this HDMI output here. You can connect the Raspberry Pi to monitor using HDMI cable here. Just like you are connecting the TV, just like that you are connecting the monitor. Here for monitor that have the DVI port, but no HDMI port nowadays. Here you can use the HDMI to DVI port adapter or cable. You required another cable here, that is a something about the HDMI to connect with the monitor. To that means it provides a video and audio output by using this HDMI port. Very important concept. How can you connect the HDMI port? If you take the one Raspberry Pi, if you have some knowledge, you will buy one Raspberry Pi and then apply some of the tasks on this Raspberry Pi. Next one here is a composite video audio output. Here the composite video audio output here is a RCA video and then audio jack. These are all called as a composite video audio output. RCA video and then audio jack. Here what is this one here? The Raspberry Pi comes with composite video output with RCA jack. Here what is the RCA jack here? RCA jack supports the video output. RCA jack can be used to connect the old type of TV, not a new type of TV that have the RCA input only. Here it will, this particular RCA jack connect to the old type of TVs. Here coming to the audio output. Here what is an audio output here? Audio output here is a Raspberry Pi has the 3.5 mm audio input jack. This is used for, what is the main purpose of this output port, this audio output here? That means providing the audio output to old TVs, for providing the along with the RCA jack for video. Here providing the audio. For this purpose you are using the this combination RCA video and audio jack. Yeah, that is a simple information. Coming to the seventh, next one here is a GPIO. It's very important one here. GPIO, where you are identifying the GPIO pins here, you will identify the GPIO pins in the top. The top of the Raspberry Pi consists of GPIO pins. Here, what are the GPIO pins here? The Raspberry Pi comes with the number of GPIO pins. That means your categories or totally different pins are there. GPIO pins, GPIO, GPIO 14 pin, GPIO 15, GPIO 8, and then GPIO 22, 23. GP like that you have a different GPIO pins are there. Here I2C interface pins here divided into four different categories. Here divided into four different categories. One is a I2C interface pins, other one is a SPI interface pins, other one is a serial receiver pins, and then transmit pins. These four are different categories of pins. Here GPIO comes with the different pins. Here this is called here GPIO pins structure. This is a GPIO pin structure of a Raspberry Pi. Here that means it consists of some voltage here. The voltage in the sense two 5 volts pins, and then two 3 V3 pins are present on the board. You may use, that means it's, I think it's a new version of pins that consists of some of the voltage pins. Other one here is a output pins. Here what are the output in GPIO pins? GPIO pins designed as an output pin can set high to high in the sense the 3 high, 0 volt in the sense low, and other kind of pins, input pins. What about the input pins here? It is used to read a high or low value. This is made easy with the use of internal pull up and pull down resistors. That is a simple information. Some output pins, input pins. Here other one here is a serial pins. Here what is the serial here? The serial interface pins are transmit or receiver pins. What is the necessity of this transmit and receiver pins? Here we have a TX and T pins are there. transmit and receiver pins. Here, what is the necessity of these pins here? For establishing the communication, for communication with the serial peripherals. Here, for providing the communication with the serial peripheral, you will use a receiver and transmit pins. That is a simple information. Other important one here is a SPI pins. Important pins, serial peripheral interface is an asynchronous serial data protocol used for communicating for the one or more peripheral devices. Here, for, for performing communication with one or more IoT devices, you are using the SPI pins. You have a different 5 different SPI pins on a Raspberry Pi. Here, what are those? MISO, master in, master slave out, and then MOSI, master out and slave in, and then serial clock, and then SIP enable 0, SIP enable 1. Here, these are all called as a SPI interface pins. 5 master, MISO, master line for the sending data to the peripheral, and one MOSI, slave line for sending the data to the master. That is, these are all different pins, pin structure in a GPIO. And then serial clock. For what about the serial clock here? The clock generated by the master to synchronize the data transmission. Here, enable or disable device. This one also a enable or disable device. This is a something about the different interfaces. Other one is a Raspberry Pi interface. In the Raspberry Pi interface, GPIO. In the GPIO, I2C interface pin on the Raspberry Pi allows you to connect a hardware modules. Here, if you want to connect the hardware module here, you use a I2C. Here, this particular I2C allows a synchronous data transfer with 2 pins. Here, what are the synchronous data? You are sending some data. It will reach. Definitely, it will reach. That's called a synchronous. Asynchronous data in the sense, here mobile phone, tower to mobile phone. That's called here asynchronous transfer. And then SDA data line, SCL clock line. By using these clock line and SDA and SCL, you will allow the synchronous data transfer. That is a simple information about the GPIO pins. Other type of information is there. Display serial interface. What about the serial interface? One of the component of the Raspberry Pi. Here displaying the serial interface. Here used to connect an LCD panel to the Raspberry Pi. LCD, that means what about display serial interface? By using this display serial interface, you will connect it to the LCD panel to Raspberry Pi, and then camera serial interface is there. Here, what about the camera serial interface? Used to connect a camera module to the Raspberry Pi, and then other one here status LED. Here the status LED having the different 5 status LEDs. The LED in the sense light, ACT, PWR, FDX, LNX, 100. These 5 are called as a status LEDs, showing the status, SD card access, whether SD card placing or not. And then PWR, 3.3V volts power is preset. And then FDX, full duplex LAN connected. And then LNX, link or network activity. Like that, you have a different modules are then different components are there. Here, in addition to this component, you have a one SD card slot. Here, Raspberry Pi do not having the built-in operating system and storage. That's why there is a requirement of a SD card slot. Okay, thank you.